Good morning, students. In today's session, we will study Introduction to Programming Languages. Before moving to the object-oriented programming language, we will study what exactly is programming language means. It is common features that is related to all the programming languages that are object-oriented. Firstly, what is programming language? Programming language is having some words, symbols, rules. That means if we are talking about high level language, that means it is having some symbols and some protocols, that is called rules, that we have to follow by writing the program. Problem to solution. Why we write our program? What is the requirement to write a program? First thing is we are having some problem that we want to solve by writing a program. Example, as we are working on some project, that means project is like a problem for us, and then we go step by step procedure from problem to solution. First step is problem. We identify our problem, that what is the problem that we are going to implement. Then second step is algorithm. If we are having some problem, then we go for its algorithm. That is step by step procedure. Algorithm means a logical and mathematical model that we design to elaborate our problem. Then is flowchart. This is diagrammatically representation of our problem. Then the programming language that we choose, either basic, Visual Basic, C, C++, C Hash, Java, Perl, Python, whatsoever be the programming language, it will depend upon the programmer or the problem that we are going to solve. And after implementation, we go to the final step, that is the solution of the problem. Here, we will take one example to show how we move from one step to the another step. As I'm saying, we are having some problem. Let's take an example that we are having problem to solve add two numbers. This is our problem. In this problem, we know we have to add two numbers. That means we require two numbers. Let's take an example. We're having a equal to 10 and b equal to 20 that we are going to solve, and the procedure to solve or the logic to solve the addition of two numbers is c equal to a plus b. These are the variables. How we will write an algorithm? This is our problem. First step is I will make one problem feature is like add two numbers. Here you are provided with a problem that you have to add two numbers. This is your problem. Then your second step is algorithm. In your algorithm, as you can see in presentation, here the steps has been determined. Step 1, step 2, step 3. How you will solve it step by step procedure. Step 1 will be, I said algorithm is, I will write here algorithm. Algorithm is what? Algorithm is step by step procedure. Mathematical and logical model. Mathematical and logical means we're going to skip which header files are required and which functions are required. We will just write a mathematical approach and logical approach. Or mathematical approach to add two numbers is we require two numbers. That means we require input A and B. Step 2 is C equal to A plus B. Step 3 is print C. Step 4 is end. It will depend upon the problem that how many steps are required from problem to solution. In this particular problem, you just require two variables where you give the values. I said input A and B means you give the values to the variable. Then I said you have to add A and B, then print the value of C. Whatsoever the value of C will be get printed. This is the algorithm. Then I said flowchart is there. In the flow chart, first is start. This is the oval symbol. Then in rectangle, I will put input A and B. Then is the operation C equal to A plus B. Then is out for the output, we use print C. Then is stop or end in the flow chart. This is the flow chart for this particular problem. Then is writing source code or writing a programming language. A programming language to solve two numbers. Hash include iostream.h. Hash include conio.h. Then is void main section. Then is you have to use int a equal to 10, b equal to 20. Here I am using some constant values. C equal to a plus b, then C out, C get ch. You must not be aware of the syntax that what is C out, why I'm adding iostream. That we will come later on. This is just a programming language program that is written in C++. Either you can write in C. This is the programming language that I have chosen. Now coming back to your presentation. Actually, this is the common step that is followed by all the industries. That how they will move from problem to solution. After writing C++ program, you will find the solution that after the implementation, you will get the solution of your problem. Basically, this is the easy one. That is, you have to add two numbers. Either you are going with any problem, any complex problem, you are going with any project, you have to go by all these steps. This is a mandatory condition in an industry that you have to first find out the problem, that is problem identification is there. Then you have to design an algorithm, then you have to design a flow chart, then only you can go for implementation. It is not like you can directly go for, you are provided with a problem and you will directly write your code. But in your course, you can write the implementation directly, but exactly what happens in a industry that you have to go by step procedure. This is the way that you will go from problem to solution. Further is types of programming languages. We're having 5 type of generations in our programming languages. First is programming language is divided into two parts. One is called the low level language, other is called the high level language. You must have listened about middle level language or mid level language when you're going to study C++ features. I will come over it later on, that why it is called mid level language. What does it mean? Firstly, we will cover all the generations, that what is first generation, second generation, third generation, fourth generation, and fifth generation. Firstly, coming to your first generation, that is machine level language. Then is I will come with an example over the board. Firstly, I will define what are the examples of the generations. First generation language is machine level language. Second generation language is assembly language. Then is third generation language is C++, Java, Visual Basic. Fourth generation language is Perl, Python, Ruby, SQL, MATLAB. Fifth generation language is Mercury, Perl, OPS5, and so on. For your understanding, I will give you examples of machine level language and assembly level language. And now you are studying third generation language, that is C++. Here I come with an example of first generation language. Is it machine level language? Generally, when the question is asked, what is machine level language? We say a language which a computer understand is called machine level language. Language which is in the form of 0 and 1 is called machine level language, which is in the form of digits, in the form of bits. Okay. Machine level language example is 0, 1, 0, 1, 1, 1. This is an example of machine level language. Are you able to understand what I have written? No, we're not able to understand. For us, it is just the digits or the bits which is in the form of 0 and 1. Then comes the assembly level language. By the examples, you will come to this point that why we require third generation language, why we require high level languages. Assembly level language means which is above the machine level language. Suppose you have to move two numbers. I said move A, comma B. You have to find the complement of any number. You will write CMA. Firstly, if I said I have written 0, 1, 0, 1, 1, 1, it means move. You won't be able to understand that I have written move. Okay. For this, you are able to understand little bit that I have written move, but the exact spelling of move is MOVE. Okay. If I'm saying you this is complementary, you have to find the complement, then you will write CMA. For you, it is CMA. I'm saying it is a complement, then you are able to understand that yes, this is for the complement. This is called assembly level language. I will give you few examples related to it. Suppose you have to add two numbers, you will write add. You have to subtract, you will write subtract. These are the common words that I have written here. I said you have to stop the program. Then I will use HLT. You won't be able to understand what is HLT. HLT means halt. Halt means stop. If I say you have to halt here, you have to stop here, you have to end here, you are easily able to understand what does my mean that I want to stop you. I want you to end your program. But if I say HLT, you won't be able to understand that I am saying you have to stop here, you have to end here. Okay. This is assembly language. Assembly level language is going to be converted into machine level language when we write our program in assembly level language. Computer is not able to understand the assembly level language as well. It has to be converted into machine level language for better understanding. Then comes the third generation language, that is called the high level language. I said C or C++ is an example of your third generation language. Okay. That we are going to implement in our syllabus. If I write hash include iostream.h. You could be possible you are not clear with the meaning that why I have written iostream.h, why I have added this header file. Rather, this is an header file. There are some questions, but you are able to read it. That hash include iostream.h is written. If I write here void main, then you are able to understand that I have used the word void main that is written in general English language. This is called the high level language. Okay. I said C++ is called middle level language because in C++, it is possible that you can write assembly language and high level language code. In C++, it is possible to write your assembly level language as well as your high level language. That's why it is called, it is a middle level language. Okay. The rest is fourth generation language, the Python and Perlog, that you will study in your further classes, that I'm not going to elaborate here. That for you, the examples are required. What is the fourth generation language? I will give you example when you go with the research work or some data science work, and for some implementation of research practices, then you will use some MATLAB or Python or Ruby, or some databases are there. When you are covered with your artificial intelligence, then you use the Perlog, Mercury, OPS 5. Okay. With the high level problems, you will use the fourth generation or fifth generation languages. Then comes the difference between machine level language and assembly level language. In the hierarchy level, machine level language is the lowest level in the hierarchy and has zero abstraction level from the hardware. It means it is at the bottom. It can directly interact with the hardware. You don't need any intermediate, that if you have written your machine level language code, then you don't need to convert it into another format that your computer or your hardware can understand. If I have written 101011, that means it is understandable to the hardware, that it means to add or whatsoever the operation that I want to give. In the assembly level language, it is above the machine level language in the hierarchy, so has less abstraction level from the hardware. That means it can't be directly connected to the hardware. It requires some tool where the assembly level language will be get converted to the machine level language. Then is learning curve. It is hard to understand by humans. That is machine level language. As I have given you an example, that if I will write 1010 instead of writing add, it will be difficult for you to understand. Assembly level language, it is easy to learn and maintain as compared to machine level language, but not as compared to your high level language. Okay, you are able to understand little bit. Let as I have written move, add, subtract, then you are able to understand that what operation that I want to do. But if I say HLD, you won't be able to understand what I have written. It is easy as compared to machine level language, but it is difficult as compared to your high level language. In machine level language, the language is written in the form of 0 and 1s in the form of bits. Then in assembly level language, it is written in English and it's easy to understand, but not in that particular type of English that you are able to understand. As we are comparing machine level and assembly language, then as compared to both, assembly level language is easy. If we uh, talking about assembly level language, I will give you example that your processor that you are using in your computers are using assembly level code. All the companies are using assembly level language for uh, making their processors. Generation, machine level language is first generation language, assembly level language is your second generation language. Requirement for translator or assembler, the machine code is executed directly, so no translator is required. That I have cleared you earlier that there is a direct interaction between the hardware and there is a direct interaction with the hardware, so there is no need to convert your code into any other format. In the assembly level language, you need one assembler where you convert your assembly language to the machine code. Whatsoever the language you are using, either the first generation, second, third, fourth, fifth, you have to convert into machine level language so the hardware or computer can understand. Then there are certain tools like assembler, compiler are available. As we are talking about third generation language, for the third generation language, we require compilers which convert your code into assembly language. Then it will be get converted into machine level language. That means step by step procedure is there when we move further with the generation to generation. Then difference between low level language and high level language. First parameter is level of understanding. Low-level language is machine-friendly, easily understood by the computer or hardware. High-level language is written in simple English. Time of execution. Low-level language takes time to execute. High-level language executes at faster pace. The speed of execution of high-level language is high as compared to your low-level language. Tools required. It requires assembler to convert your assembly code to the machine code. In high-level language, we require compiler that converts your high-level language to the machine code. Portability. Low-level language is not portable. Portable means transferable from one machine to the another machine. High-level language is portable. Suppose you write your code and you have written your code at your laptop and you want to run your code at your college computer system. You can use the USB, you can put the source code there and you can run your code here. But low level language, you cannot transfer your code from one machine to the another machine. Then is memory efficient. Low level language is memory efficient. High level language is less memory efficient. Debugging and maintenance of low level language is not easy. In high level languages, the compiler are having inbuilt debuggers which will help you to execute your program correctly. So it is easy to debug and maintain in your high level language. These are the common practices when you are going to write your code. First is naming conventions. As I'm saying, naming conventions means, let's take an example that you are going to add two numbers. Here I will give you one example here. I said these are the rules that you must follow while writing a program. These are not the mandatory rules, but make a habit when you are going to write your code, try to follow these type of rules. First is the naming convention. I said add two numbers. Okay. I will use header file here. Use void main directly. If I said int, I will write my name here or Neha equal to 10, CS equal to 20. And I said int class equal to Neha plus CSE. Cout class. First, instead of class, because class is a keyword, I will write here B2. Okay, B2 equal to Neha plus C. It's like Neha, CSC, Neha equal to 10, CS equal to 20. This is not a proper format. You must use that name that is suitable to the program. If I say int instead of Neha, if I say int equal to 10, yes, A is a variable. Neha is also a variable. CS is also a variable. But this is not a suitable variable because as we know, Neha is a name. It's in the string format. Then I'm using it as a variable. This is not suitable. Use that variable names very carefully that is suitable. B equal to 20. I said int C equal to A plus B. Then you are easily able to understand that I'm going to add two numbers. On naming convention say I'm going to give name of our problem like अगर मैं इसको से पढ़ती हूँ with the name of welcome.cpp. You will open your program with the name welcome.cpp, but the code is written here is the addition of two numbers. You won't be able to understand at once that what has been written here. Use proper name formats whatsoever the name of your program, what the operation that you are going to perform, give the particular name so that you can easily understand what is the code all about. If I write here add.cpp with the name of the program, it will be very clear to me that it is a program to add two numbers. Okay. Then comes the commenting. Commenting means it is mandatory to give comment in front of your program. This is the easiest one. This is 4-5 line code. That is not an issue that if I will read. But when you are going to write your project that is of thousands of lines, it will be very difficult for you to remember or cram all the functions and all the classes that you have written, that what is the functioning behind that function, what is that particular function performed. So it is better to give comments here. Suppose yeah, in this I'm going to give two numbers. I will make a comment here. Input two numbers. Here addition of two numbers. Here output. It is not mandatory for the smaller program, but when you are going to write your project, this is mandatory condition. You must write for your remembrance so that whensoever you open your project, it will be easy for you to understand. Then is indentation. Indentation means using proper spaces. If I am writing here parentheses, then if I'm closing that parenthesis here, sometimes we get an error, parenthesis error is there. Okay, compound statement missing. Suppose you have opened two parentheses, here in between you have closed. Let's take an example here. I have opened here two parentheses, in between I have closed that parenthesis here. I have to look for that where is my parenthesis has been closed. So give proper indentation so that I can easily able to find out where my program has been started, where my block or code has been started, where it has been ended. If I will write parenthesis here where I have started exactly under here, then it will not confuse me, or you can check your error will be get removed very easily, especially of parenthesis error. Then comes the follow DIY principle, that is don't repeat yourself. This is one of the feature of C++ that you don't have to repeat the code again and again. You can call the classes, you can call the objects anytime. So try to avoid repetition. If there is a repetition in the program, then try to avoid it. This is the general practices for writing better code, for minimizing your code so you can write better. Then comes the comparison of Turbo and Dev C++. In your sessions, we will study Turbo C++, but if you are having GCC compiler Dev C++ or CodeBlocks, you can go for it. In C++, Turbo C++, there are two header files, Conio and IOStream. Conio.h is extra, which is not present in the code of Dev C++. This header file basically contains the getch function, which is used to return the program successfully. The basic purpose of writing getch in your code is to hold the screen. But in Dev C++, there is no requirement of the Conio as the getch function. The programming of getch function has been written in the Conio.h, but in Dev C++, there is no requirement of the getch function. Namespace, second point is namespace contains the basic cin and cout other keywords, but we do not use it in Turbo C++ because we write iostream.h, which contain everything in itself. In Dev C++, we use namespace std because the header file iostream does not contain cin, cout. Here in Turbo C++, we don't write namespace. We write iostream.h. As you have written, as you have seen, I have written a program to add two numbers. Then I have added here to one header file, that is iostream.h, because I have used the function cout. In Turbo, cin and cout working has been explained in iostream.h, but in Dev C++, the working on cin and cout has been defined in namespace std. In Turbo C++, previous program data is saved as garbage and next time appears on screen, so clear screen function is required. CLR, SCR, that is clear screen. CLR stands for clear, SCR stands for screen. This function is required when you are going to clear your previous output. It will be get more clear when we go with the implementation of the problem. But in Dev C++, each time after the compile and run, a new window pop-ups. So we do not need to clear screen used by the previous program. That means there is no requirement of getch function and clear screen function in Dev C++. I must tell you one thing, that the file conio.h contains both the functions. The working of both the function clear screen and getch is contained by conio.h. As conio.h is not available in Dev C++, so we don't have to write both the functions clear screen as well as getch. In Turbo C++, graphics are installed by default. In Dev C++, you have to install graphics manually when you are going to work with the graphics. Moving further, comparison of C++ and GNU. It Turbo C++ can be run on Windows as well as on Linux. GNU generally works on your Unix and Linux operating systems. Turbo C++ is developed by Borland. GNU is developed by Free Software Foundation. In Turbo C++, it has menus, mouse-based interaction facilities as well as graphical user interface, but GNU is a command line interface. If you have worked with the disk operating system, that is with the MS-DOS, you must have seen that we use command line interface there. Similarly, when you're going to use your GNU, then you will use your command line interface. Okay, moving further to your unit 1, the content that we will cover in this session is history of C++, introduction to C++, application areas of C++, difference between procedural oriented programming and object oriented programming, difference between C and C++, features of C++, and basic concepts that are related to your object oriented programming. Coming to the history of C++, firstly the name given as C front, then C pre, then C with classes, then C++. C++ was initially known as C with classes and was renamed C++ in 1983. Plus plus is a shorthand for adding one of the variety in programming. Therefore, C++ roughly means that one higher than C. The developer of C, Bajan Startup, used C with some enhancement features of object-oriented. C++ is not your first object-oriented language. Simula 67 is the first object-oriented language where the working over the object with function and data has been found. But Startup used C with objects working over the object. It he thought that it is some enhancement with the C. So plus plus the shorthand operator is used in front of C plus with the in front of C language, and it is given the name as C++. The C++ has been started in 1978, but it is completed or created in 1979. The name has been modified in 1983. The developer of C is Bajan Startup. He was from Denmark. The name suggested along with the developer as the C++ is Rick Marcy. Then is introduction to C++. C++ is a basic language that is high level, compiler based, object oriented programming language. This is general purpose. General purpose means different type of softwares that we can develop while using the C++. First is the operating system, then editors, then some commercial application, databases, translators, device drivers, games, protocols. These are some type of softwares that we can develop while using C++. If I'm saying C++ is general purpose means it can be used in either field. I will give you one example here. The operating system Microsoft XP is also developed in C++. Some kernels, drivers can be developed by using the C++ language. Applications area of C++, user interface design such as Windows menus, real-time system, simulation and modeling, object-oriented databases, AI and expert system, neural network and parallel programming, decision support and office automation system. Now coming to the difference between procedure-oriented programming and object-oriented programming. Basic definition is OOP stands for Object-Oriented Programming and POP stands for Procedure-Oriented Programming. Program division, as the name suggests, object-oriented programming, so program is divided into objects. As in the procedure-oriented programming, the program is divided into functions. Here the emphasis over the object, but in procedure-oriented programming, the emphasis is over the functions. Approach is bottom-up approach. Procedure-oriented is top-down approach. Now let's differentiate between what is the bottom-up approach and top-down approach. Bottom up approach means that you can write your main function and you can define your functions later on. But in procedure oriented, you have to complete your program completely. Then only you can run your program. You can't wait for the functions to be written later on. Then comes the data control. Data in each object is controlled on its own. In procedure oriented, each function has different data, so there is no control over it. Entity linkage. Object functions as link are linked together through message passing, that one object can communicate with other object via some functions. In procedure oriented, parts of program are linked through parameter passing. Some parameters has been passed with the functions, that it is called parameter passing. I will give you one example. If you have if you are using exit function, you must have written exit 1, exit -1, exit 0. Whatsoever the value you have given in the exit will be considered as a parameter. And if you write clear screen get ch, you can check, you don't give any value here, it is empty function, it is void function. Then expansion is there, adding new data and function. Expanding, adding new data and function is easy, but in procedure oriented, expanding data and function is very difficult. It is not an easy task. Here in procedure oriented, the inheritance is ported in 3 modes, but in procedure oriented, there is no concept of classes, there is no support of inheritance is there. Then comes the access control. With the concept of classes, we use access control modifiers or access modifier, where you can make your data as public, private or protected. In procedure oriented, there is no such support to the access modifiers. Data hiding. Data hiding is known as encapsulation. Data can be hidden using encapsulation in object oriented. In procedure oriented, no data hiding is there. Overloading and polymorphism. Overloading functions, constructors and operators are done in object-oriented programming, but in procedure-oriented programming, no overloading is possible. Friend function, classes or functions can be linked using the keyword friend only in C++. In procedure-oriented, no friend function is there. Virtual classes or functions. The virtual functions appears during inheritance. As there is no concept of inheritance, so there is no concept of virtual classes or functions in the procedure oriented. Code reusability. The existing code can be reused in the object oriented. In procedure oriented, there is no code reusability. Now coming to the approach of difference between C and C++. In C, it is structure or procedure oriented programming. We have already seen the features of the procedure oriented programming. Now coming to one of the example of procedure oriented programming, that is of the C. The C++ is object oriented programming language. C uses top down approach. C++ uses bottom up approach. In C, polymorphism, inheritance, and data encapsulation is not possible. In C++, polymorphism, inheritance, data encapsulation is possible. In C, there is no data security. In C++, there is data security. Data abstraction, data hiding is not possible in C. Data abstraction, that is data hiding, is possible in C++. Function overloading and operator overloading is not possible in C. Function overloading and operator overloading is possible in C++. Generic functions are not possible in C. Generic functions are possible in C++. Generic functions are generally used with the templates. that feature is available in C++, but it is not available in C. In C, we use the calloc and malloc function, which is used for the memory allocation and deallocation. And for the deallocation, we use the free function. In C++, we use the new and delete operator for the memory allocation and deallocation. When you are going to make your project using file handling, you have to allocate the memories and deallocate the memories. In C, you must have used calloc and malloc function, and to release that memory, you have used free function. But in C++, when you want to allocate the memory, then you use the new operator. But when you have to deallocate the memory, then you have, but in C++, when you have to allocate the memory, you have to use new function, but when you have to deallocate the memory, you have to use the delete function. Then in C, the file extension is .c. When you're going to save your file over the IDE, you must have used .c, but in C++, file extension is .cpp. C++ features middle level, structured, rich library, object-oriented, recursion, pointers, compiler-based, faster, extensible, memory management, simple, portable. Now, first coming to the first feature, that is the simple. Simple is C++ is simple language in the sense that it provides structured approach to break the program into some parts. Then comes the portable. The second feature is portable. Portable means like assembly language, C program can be executed in many machines. As when the portable word was there in assembly language and machine level language, I said you can transfer your program from one machine to the another. C++ is having this feature that you can you can port your one program or your one code from one machine to the another. Then comes the middle level programming language. As I have already told you that C++ is having the facility to write the low level language, to write the assembly code that is used for the designing of kernels and drivers. So it is called the middle level language. Then comes the structured language. Structured means C++ is structured programming language in the sense that we can break the program into part using functions. So it is easy to understand and modifiable. Then comes the rich library. C++ provides a lot of inbuilt functions that makes the development fast. As you, when you are going to use, here I'm taking one example, as you are going to use clear screen function. Maybe possible that clear screen function has 1,000 lines of code. Each time you have to type 1,000 lines of code, but C++ facilitates you by writing the library or by using the header file conio.h. You can directly use the functioning of the clear screen. Then is the memory management. It supports the feature of dynamic memory allocation. In C++, we can free the allocated memory at any time by calling the delete operator. Then is faster. The compilation and execution time of C++ is fast. Then the pointers. C++ provides the feature of pointers. We can directly interact with the memory by using the pointers. We can use pointers for memory, structures, functions, arrays, etc. Then the recursion. In C++, we call the function with the function. That means a function call itself is called the recursion. Extensible. C++ is extensible because it can easily adopt new features. New features, that means enhancement is possible here. Object-oriented. C++ is object-oriented, as we have studied so many features of the object-oriented like inheritance, data hiding, data encapsulation. All these features are available in C++. Compiler based, C++ is compiler based. It means without compilation, no C++ program can be executed. First, you have to compile your program, then only you can execute it.